Hello, CEP 636. So you've started working on your first assignment by now. And this first assignment involves working with the Roller Coaster Tycoon data set in SPSS. And the purpose of this assignment was really to help you understand and get back in touch with SPSS. Sort of, let's see what you remember. And I'm going to kind of go through the assignment as I posted it. And kind of show you the things that I pay attention to and the kinds of ways I would word things just to give you an idea of that from my perspective. And I think it's nice to see that because in this case, there's a lot of different directions that you could go. And so there's no one right answer. The real goal here is to just try and get your head back into thinking about statistics. So let me pull up the assignment details here. So first download this .sav file called roller coasters. That is the kind of file that will open in SPSS. And this guy, Nolan Conaway, he made this data set available on a website called kaggle.com, which is sort of a database of databases, if you will. So it's available for free. He created a lot of these things himself in the game Roller Coaster Tycoon. So we're looking at his theme park world. And I'm going to use this question that I gave in his example as what I'm going to go through to try to answer this question. How fast are the roller coasters in Nolan Conaway's parks? And then your goal was to write up the results of description, including measures of center spread and shape, and including a histogram and box plot for your data. So I'm going to switch now over to SPSS. So when you open it, you get a lot of different options here for the data that could have to do with how fast the roller coasters are. The most obvious ones are these two, max and average speed. However, there's some other ones that you could also look into. Let me make this a little bigger. So in excitement and intensity, for instance, those are things that relate to speed. I would think when things are faster, there's more excitement or more intensity. But there are other things that could relate to intensity and excitement that are in this data set, such as, especially these last ones here, the max positive Gs, the max negative Gs, the max lateral Gs, total air time, number of drops, highest drop height, and inversions all probably also relate to ratings about intensity and excitement of the ride. Whereas things like ride time or ride length probably don't have much influence on excitement and intensity. And we could look at those things later, but for us, I asked you just to look at one variable and think about how to answer your research question. So let's do this. Let's say we're going to look at both max and average speed just for the purposes of understanding this idea of how fast are the rides. So if you go under Analyze, Descriptive Statistics, and Explore, imagine that, right? Explore. We want to explore the data. This gives you a lot of output at once. I've already put them in here, but put max speed and average speed in the dependent list. In a previous video, I put something in the factor list. At this point, that's not something that's going to help us answer our research question necessarily right now, although we could put something like custom design in there to understand how fast are the roller coasters that Nolan Conaway created as opposed to those that came stock in the game already. But for now, let's just do these, and we're going to get two sets of output here, one for max speed, one for average speed. Under statistics, you could select these other things if you want to. The outliers, percentiles, I am not that interested in those right now. There are other ways to get that information. And by default, this comes as checked with stem and leaf plot. As I mentioned in a previous video, I don't like stem and leaf plots very much. I prefer histograms. You can include the stem and leaf plot if you want, just to see what it looks like. Normality plots with test go ahead and check that. That is not checked by default, and I'll walk through what that means here in a moment. Under options, we want to exclude cases listwise in case there is missing data, and then make sure that under display, the both option is selected there. You want both statistics and plots. Click OK, and it will show it here in the output, which is kind of small on your screen. So I have already exported this as an HTML web report, which you may find useful to you, especially if you're going to look at output later on a screen that does not allow for, or on a computer or device that you don't have SPSS on. You can export the output and open it with any kind of web browser. So it's kind of nice. All right, so I've selected the descriptives tab here. There's also this case processing summary. This will be the first thing in the output that you see, and you'll notice there's 142 roller coasters. That's what each row represents. This N. There's nothing missing here in the middle. So there's 142 in both for max and average speed. If we click on the descriptives piece, all right, so the first thing here you see is max speed section of the table. The mean is 43.57. So that means that the average max speed is 43 miles per hour. The trimmed mean is 5% trimmed off on both sides. So you can see whether or not the mean is being impacted by outliers, which it doesn't seem like it's being impacted a lot, not even 1 mile per hour. But there is something there, so it seems like there is some bigger values on the high end. And the median is 42 miles per hour, 42.5 miles per hour. And the median, remember, is calculated as the 50th percentile. So if you take all of the max speeds and put them in order from smallest to largest, it is the middle value. So since there are 142, I think was right. Yeah, 142 values. So if you divide 142 by 2, you get 71. So if you put all of the max speeds in order from smallest to largest, it is the 71st data point. So half the data points are smaller than that, half are bigger than that. And if this was a completely symmetric distribution, the mean and the median would be the same, but they're not, which means since the mean is a little bit bigger than the median, it's going to be skewed to the right a little bit. We can also tell that from the trimmed mean because it's smaller, so there must be some bigger values out there somewhere. Don't know how big yet. The variance is just the square of the standard deviation. The standard deviation is much easier to understand. And notice when I select standard deviation, it selects the mean because the standard deviation is the average deviation from the mean. So on average, the max speeds deviate about 9 miles per hour from the mean. The minimum is 29 miles per hour. I hope that's a little kid ride. Otherwise, it would probably be pretty boring. Very low on the excitement scale. Maximum 89 miles per hour, which is a range of 60 miles per hour. The interquartile range is 9 miles per hour, which is visible on a box plot, the same as the median is visible on a box plot. And the interquartile range includes the median. It is the range of the middle 50% of the data. So from the 25th to the 75th percentile, that range, what the distance is between those, the 25th and 75th percentile, or Q1 and Q3 as they're referred to. 9 miles per hour. Skewness and kurtosis values. Skewness is a measure of skewness left or right. 0, if the skewness is 0, that means it's perfectly symmetric. And then, of course, positive means skewed to the right, negative means skewed to the left. And then kurtosis is a measure of peakedness. So how steep is the peak, and or how flat is it, if it's sort of squished down or not. These values, a general rule of thumb that is used is that they should be within plus or minus 2. So the skewness seems okay. It's not quite up to 2 yet. And kurtosis, though, is beyond 2. So there may be some issues with the max speed variable. Okay, moving on to average speed. We see a mean of 14, trimmed mean of 13 miles per hour, almost 14, so not much difference there. A median of 14, so the mean and the median being pretty much the same indicates pretty good symmetry is likely. The standard deviation is about 5 miles per hour. Minimum is 1 mile per hour. Wow. A minimum average speed of 1 mile per hour. Well, I guess that makes sense, right? When you're first starting out a ride. And the maximum average speed is 44 miles per hour. Although for the average speed to be 1, that just seems impossible to me. But okay. Interquartile range is 4. So that's the middle 50% has a range of 4 miles per hour. And skewness and kurtosis, there are big issues. Both of those are beyond 2. Kurtosis is really big, which means there's going to be probably a pretty big peak at some point. Pretty steep incline. All right. Next is test of normality. There are 2 different tests here. Kolmogorov-Smirnov and Shapiro-Wilk. These tests both have a null hypothesis that says that the data is normally distributed. So if you have a significance or a p-value that is really small, then that means that it's highly likely that you don't have a normally distributed distribution. And no matter which test we're looking at, both of these are indicating non-significance. They're saying, nope, we don't have evidence to support that. It looks like it's probably not normal. So let's look down here at the plots. So if we look at the histogram, the first histogram here is for max speed. And you can see these pieces on the right around 70 and closer to 90, 85, 90 range. Those are pulling the mean up, and that makes it skewed to the right because the tail is on the right side of the graph. And you can see here that the kurtosis is probably high because this is kind of a steep incline here at the beginning, with some lower bars on the right especially. And it conveniently reminds you of the mean and standard deviation here in the plot. And the other thing that is helpful to look at is the normal QQ plot. What this does is it maps the observed value, which in this case is max speed, onto what would be expected if it was actually a normally distributed data set. Now, this is assuming perfect normality. Every dot would be exactly on this line that you see here. And there are 3 data points that are below the line that deviate in a pattern off of that line. And of course, those 3 are the same 3 that we saw in the histogram that were in the far right, around 65, 69 it looks like, 69, 85, and 89. So those 3 roller coasters are deviating, and then there is some slight deviation too here on the left side of the graph we can see. So this is also evidence that we do not have a normally distributed data set. Max speed at least is not normally distributed. And then if we look at the box plot here, this first line down here at the bottom is the minimum, which it's not showing me what it is, but it was 29, I think. And then the first line on the box plot is Q1, the 25th percentile. So 25% of the data is here between the minimum and Q1. And then another 25% up to the median, which means this 25% plus this 25% makes the 50%. Remember, the median is the 50th percentile. 50% of the data is less than, and 50% of the data is greater than it. And then another 25% is between the median and Q3, which is this, the top part of the box here, or the right part of the box if you think about it sort of turned. But high end of the box. And then actually the next line is here. You just can't see it because it's overlapping with this line on the graph. This is the max, which actually is called the upper fence at this point because there are these 3 data points that are considered outliers that are up here. So those outliers are decided upon by taking this distance inside of the box and multiplying it by 1.5. So one full distance of the box plus half of that box's distance. And that is where this line is drawn. So you take that distance, imagine taking this box here and sort of adding it to here and then adding half of that, and then we make it up to here. And anything beyond that's considered an outlier. So that's how it does it for the most part. There's different ways sometimes they do this, but that's the most common way. And so you can see that if you think about the box plot without the outliers, it seems fairly symmetric, which if we look back at the histogram, we would see that that's probably the case, although this whisker here, this is the whisker part of the box plot, box and whisker plot, as it's sometimes referred, is a little bit longer than this one. And if we think about the distance from the median to the minimum and the median to the maximum, it's not quite symmetric. They're not the same. So there is even a little bit of asymmetry there once we remove the outliers. So if I was going to answer my research question, which the research question was, how fast are the roller coasters in Nolan Conaway's parks? What I would say is, first of all, I want to describe center spread and shape. And shape can be described helpfully, was really helpful to describe when looking at a histogram. But first I would look back at the descriptives and I would say, as far as the max speed goes, the center is around 42 or 43 miles per hour. The mean is 43 miles per hour. The median is 42.5. With a standard deviation of around 9 miles per hour and a range of 60 miles per hour. The interquartile range is 9 miles per hour, which surrounds the median. And in general, the data are skewed to the right with outliers in the 65 to 89 mile per hour range. So even though the mean is 40, the center is around 42, 43 miles per hour, there's quite a lot of spread involved. And a lot of that has to do with these outliers that are out here, which is why we see the interquartile range to be quite a bit smaller than the standard deviation would indicate. So the standard deviation actually, if this was symmetric, about 2/3 of the data would be within plus or minus 1 standard deviation. So that would be a range of 18 miles per hour around the mean, whereas the interquartile range shows 50% of the data within a range of 9 miles per hour. So that's quite a big difference. All right, and that is where I'm going to stop, and let me know how things go with this. Watch this video to see, reflect on what you did for the assignment, and then we will go from here. I hope things are going well for you.